All right, sorry about that. OBS crashed. Let's try that again. All right, Unit 3. This is all about transformations. Explain what is the difference between a rigid motion and a non-rigid motion. Can you give an example? Can you give examples of each? What is the same? What is different? Okay, so a rigid motion, as you can tell, I already wrote this earlier. A rigid motion is something that preserves congruency. So it means it's going to keep the shape and keep the size. So three common ones that we use are translations, rotations, and reflections. Translations are also known as shifts or pushes. Rotations are seen as twists, and reflections are seen as flips. Okay. A dilation does not preserve congruency. It preserves similarity. It'll have the same shape, but not necessarily the same size. And a dilation has to have a scale factor that's not a non-zero scale factor. So if it's between 0 and 1, it's going to be a reduction. It's going to shrink. And if it's larger than 1, it's going to be an enlargement. It's going to get bigger. Okay. What's different? So it's the same. Okay. Well, they're both going to be working off pre-images, and they're going to result in an image. What's different? Well, non-rigid is going to change the actual size of the object, okay? Whereas the rigid motions will not. Okay, translate DUG using the following shift. So we're going to go 3 to the right. Okay, there's two ways of doing this. You can write the coordinates and apply these values, or you can think of it in terms of directions. So I find it a lot easier to go directions. So when you're adding 3 to x, you're going to go to the right 3. And when you're subtracting 1 from y, you're going to go down 1. Okay? But we can do the coordinates too. We'll do both. Let me go ahead and find a piece of paper I can write on here. So let's go ahead and we'll do the coordinates here. So G, U, and D. So G, U, and D. G is going to be -2, 1, assuming these are all scale of 1. So -2, 1. U is going to be 2, 1. And D is going to be 1, 1, 2, 3, 4. 1, 4. So G prime, U prime, and D prime. So we're going to add 3 to x and subtract 1 from y. So we're adding 3. So -2 plus 3 is going to be 1. And 1 minus 1 is 0. 2 plus 3 is 5. And 1 minus 1 is 0. 1 plus 3 is 4. And 4 minus 1 is 3. So the resulting triangle should be the same exact size and shape as this one. So let's see. 1, 0 is here. That's G prime. 1, 2, 3, 4, 5, 0 is U prime. And 4, 3. 1, 2, 3, 4. 1, 2, 3. That's D prime. Okay. As you can see, GUD and G prime, U prime, D prime are the same shape, same size. You can also just do it this way. So we're adding 3. So we go 1, 2, 3, and down 1. I think that's a lot faster. But it's important you can see how to do both. Reflect F triangle FAR over the line x equals 2. So what we're going to do is draw that line. So if x equals 2, that means the x value is not changing, which means it's going to be a vertical line like this. Okay. Now there's no reflection rule for this, so what we're going to do is just count the distance from the points to the line of reflection and go the opposite direction and make sure they're equidistant. So A is 2 to the right from here, so A prime is going to be 2 to the left from here. F's already on the line of reflection, so that's not moving. R is 1, 2, 3, 4, 5, so we're going to go 1, 2, 3, 4, 5 here. That's R prime. So I don't have a ruler. I'll use this, I guess. Will kind of work. There you go. It's more advertising for Arbor Nutrition, I guess. Those are the primes. Okay, that's it. Given the pre-image, identify the transformation and be as specific as possible. Okay, so YPL and Y prime P prime L prime. So this went, looks like it went left and up. Ow, ow, ow. So yep, that is a translation. It's a shift. But we can be specific. Let's figure out what happened here. So Y went 1, 2, 3, 4 to the left, so x minus 4. And how many up did we go? 1, 2, 3, 4, 5. So an up 5. So y plus 5. That's translation. Okay. And this looks like a shift, but it's not, because notice J is on the left here, J is on the right here. This is a reflection. You notice the first thing I did is I drew the line of reflection. Let me just make sure it's not tilted. There you go. Okay. So this line of reflection is 1, 2, 3 is x equals 3. Reflection over x equals 3. And that's it. All right, that's page 1. Page 2. Given the image and the pre-image, this is the same thing as before. Okay, so this is not a reflection because E is here and it's up there. It's not a translation. This is going to be a rotation, and it's actually 180 degrees. 180 degree rotation. This is, and the direction doesn't matter because 180 degrees. This is a dilation because the size changed. Now the scale factor, however, it's definitely an enlargement. We can figure this out by taking the coordinates. So J is 1, 3. Oops, hold on. 1, 3. And then J prime is 2, oh, hold on, looks like 1.5. 1.5, comma, 1, 2, 3, 4.5. Okay. So it went up by 50%, which means we multiplied it by a scale factor of 1.5. So scale factor. And you can do that by actually taking this value and dividing it by that. So if we take 1.5 over 1, it'll give us the scale factor. You just take the pre-image value and put it over that of the image value, and it will give you the scale factor, if you're wondering how we did that. Okay. Using the coordinate plane below, on the graph to the left, draw BF after a dilation with a scale factor of 2. How long is the new segment? Okay, so we need the coordinates of F and B. So B is -1, -2, and F is -3, -2. So scale factor 2 means we're going to multiply it by 2. So B prime is going to be -2, -4, and F prime is going to be -6, -4. So let's graph that. So -2, let's see, where are we? -2, -4. That's B prime. And -6, -4. That's F prime. This is 2 units long, this is 4 units long, it's twice the size. Okay. On the graph on the left, draw BF after a dilation with a scale factor of 1/2. Alright, so we're going to shrink it down. Same thing. So, well, similar thing, I should say. -1, -2, and then -3, -2. We're going to multiply everything by half. So these numbers are going to half. So B prime is going to, we'll call them, we'll still call it, a little confusing. We'll call it double, I don't want to call it double prime because it's not a composite. Let's call it prime. B, actually, there's a different color, that'll help. B prime, -1/2. And then half of -2 is -1. And then F prime is going to be, let's see, -1.5 and -1. So we just multiply by a scale factor of half, so it's half them. So -1/2, -1's there. That's B prime. And -1.5, -1. It's right there. That's f prime. Okay. 9. Okay. Select 3 transformations of a triangle that result in a congruent figure. Rotation, clockwise, yep, that'll preserve congruency. A dilation with a scale factor of -1. Yep, that confuses people. So you just take the absolute value of that. So because people think it's a reduction when they see that, but that's actually would just keep it the same because it becomes 1. So yes, that would preserve congruency. This is an old MCAS question. A dilation with a scale factor of 2. Nope, that would enlarge it. Translation. Yep, that would preserve congruency. And a dilation scale factor of 1/3. No, that would shrink it. So it's A, B, and D. All right, let me pause it for 1 second, guys. Okay. Triangle ABC is shown here, reflected across the x-axis, and then translated 3 units up to create its image triangle ABC. Determine the location of ABC on the coordinate plane. Select the correct orientation and position. Okay. Yeah, this is an old drag and drop from the MCAS. So we're reflecting over the x-axis, so it's going to flip this way. I'm actually going to use 2 different colors here. So red will be the first, and then blue will be the second, which will be our final positioning here. So if we're reflecting over the x-axis, this is going to go up here. That's our C, and then B is going to become up here. B. I don't like the fact they don't have double primes here. I remember this problem bugging me when they had it. And then go 3 units up to create. Okay, so we have to shift it up now. So 1, 2, 3. That's B prime. 1, 2, 3. That's C prime. And then 1, 2, 3. That's A prime. Okay. So I guess this would be the best one, I think. Yeah, that's it. Okay. The graph below shows triangle Bro and its image after dilation about point K. Find the scale factor of its dilation. Okay. So, oh, interesting. We're not using the origin as a point of dilation. Interesting. Well, this looks to be twice the distance from that. We can actually very easily check that. So, how far is B from the center of dilation, which is K? It is 1, 2, 3, 4. Wait, 1, 2, 3, 4, 5 units away. How far is B prime from this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So because this is 10 and this is 5, well, guess what? This is double the size. I mean, you can kind of eyeball. Let's check all of them. This is 2. This is 4. And diagonally, if I'm going to go 1, 2, 3, 4 diagonally, guess what? It best be 4 more over here. 1, 2, 3, yeah. So scale factor is going to be 2. Okay. All right. Moving right along. Number 12. Graph the dilated image of triangle XYZ using a scale factor of 1.5. And 0, 0 as the center of dilation. Okay. So let's graph the coordinates of, let's write the coordinates of x, y, and z first. So x is -4, 2. Y is 6, 0. Z is -2, 1, 2, 3, 4. -2, -4. Okay. And then we're going to dial the scale factor 1.5. So we're going to multiply all these numbers by 1.5. So -4 times 1.5 will be -6. 2 times 1.5 is going to be 3. 1.5 times 6 is going to be 9. 1.5 times 0 is 0. 1.5 times -2 is -3. And 1.5 times -4 is -6. I should have done that in red. That's okay. Yeah, let's keep it blue. So -6 and 3. So 6 and 1, 2, 3. That's x prime. 9, 0. It's y prime. And then -3, -6. 1, 2, 3, 4, 5, 6. That's z prime. If you don't have a ruler when you're drawing things like this, it's actually much easier to draw something straight when you're going up and down, traditionally. All right, there you go. Which of the following transformations carry this regular octagon onto itself? So when this says carry it onto itself, that's language you're going to see on the MCAS. It's going to be very confusing to people. What it means is that what can you do where it doesn't look like anything actually happened? So which of these things, which of these options will result in this appearing to be as if nothing had changed? Okay. So reflection in point H. Nope. Reflection in point D. Nope. Reflect over a point. You need a line of reflection, not a point. Reflection over line S. Rotation 120 degrees clockwise. So it's going to be reflection over line S, and it would only work. It would only work if the points weren't labeled. It would. I mean, technically. So I guess it's not. I actually picked this question. It's not the best question, I guess. So yeah, it's going to be reflection over line S, but technically, I guess if you label the points, it wouldn't look exactly like it carried onto itself. But yeah, that's the best answer you have. Are these shapes congruent? Number 14. Explain why or why not. What type of transformation does this appear to be? Can you use to prove your answer? Okay. What type of transformation does this appear to be? So, I mean, it looks like a dilation. It looks like it changed the size, but it didn't change the shape. That's what it looks like. It's a triangle, right? So let's see here. So this has a rate of change of 2/1. This is a change of 3/1. Okay, so if I was to look at this from red going to black, this would be an enlargement, and it'd be an enlargement of 1.5 scale factor. Let's check this one right here. So this is 4/3, and this is 1, 2, 3, 4, 5/3. That's not, nope, that didn't change at all. And then this is 2/4, and this is 2/4. Okay, so this is not a dilation. So you'll notice that this length and this length are the same. Okay. And unless I'm just reading this incorrectly, no, I'm not. Okay, it's the same length. And then this length is different from that length, so those are different. And then this is 1, 2, 3, 4, 5. And this is 1, 2, 3, 4/3. So this is, yeah, so this is the same length. Hold on, I totally screwed that up. Yeah, let's write that again, sorry. So this side here is going to be 4 across, 2 down. This is 1, 2, 3, 4. This is 4. So this side is actually the exact same length as that. But then these two lengths are different. So it's actually not, it's none of those things. It's not a reflection because it's actually none of the rigid transformations because the shape and size changed. The distance between these 2 points and those 2 points is different, as are those from there. So they're not congruent, and they're not even similar because the difference of proportions is not consistent. So if I was to, let's say, take this distance over that distance and then set that equal to this distance over that distance, it's not going to be equal. So yeah, what type of transformation? It appears to be a dilation, but it's not. How can we prove it? We could prove it using Pythagorean theorem to show that these distances are different, or the distance formula. We're not going to do that because it's going to take us, what, 20 minutes? Not 20 minutes. It's going to take us, what, 5 or 10 minutes to do that, but we're not going to do that. If you want to do that, great, but you don't need to. As long as you can explain that it is, yeah. All right, that it's not rather congruent, then yeah. Okay. Number 15. Graph below shows figure B. Let's go back to that problem. It's a really good problem for a few reasons. It's forcing you to identify why these two objects are not congruent and why it's none of the 4 things you've learned how to do. Like, it's not a translation, it's not a reflection, it's not a rotation, and it's not a dilation. So, yeah, it's weird. Good problem, but it's weird. All right, number 15. figure below shows figure B and its image figure C. Describe a sequence of rigid motions that would map figure B onto figure C. Okay, so how can we get from here to here? That's what it's asking us to do. So, okay, well, you can tell that it's not just one. You tell us it's a sequence, which means it's a compilation or a composite. Okay, we're doing more than one. Personally, I would start with there's multiple ways of doing this. So this is not the only way to do this. I would reflect it first. I would reflect it over the x-axis. So if you reflect it over the x-axis, you're going to get, let's see if I can grab these squares are really small. There's that. This is -4, so this should be +4. And then this is -8. Should be +8. And this is -9, so this should be +9. Okay, so that's, if you reflect it over the x-axis, it's going to look like that. Okay, so reflection, step 1, reflect over x-axis. Step 2, we have to translate it to the left. I think that's it. We don't have to go up or down. Yep. So we're going to go 6 to the left. Translate of x minus 6, and that's it. Or 6 to the left. Multiple ways of writing that. That's it. But again, there's various ways of doing that problem. That's not like there's not one only way to do that. That's just the way I would do it. Okay, number 16. On the coordinate plane below, figure U is graphed. Figure T and V, the figures of figure U are graphed after sequence of rigid motions. Okay, so again, sequence is just a composite. There's more than one. They're doing more than one here. So this would, if we were to have points here, like let's call this A. Oh, let's go back to the original. Let's go back to this problem. So let's say this was A. That'd be A prime, and that'd be A double prime. But the MCAS doesn't seem to really, I don't know. They're not as consistent with their primes and double primes, which we'll get into later. On the coordinate plane below, figure U is graphed, figure T and V. The images of figure U are graphed. Okay, so figure U is the original, and then T and V are the images. So these things happen after that. So we're starting with the pre-image here. Identify which sequence of rigid motions maps figure U onto T and then V. Okay, so this is going to be our pre-image. Then we get this one as our image. Then we go from here to there. So I'm gonna just label this as A prime, and A double prime, because I just find that to be much easier for my brain. If that confuses you, I apologize, but that's just something to do. All right, so how do we go from here to here? Let's look. Well, there's actually a really kind of, let's go through the process here. Are we reflecting? No, we're not reflecting. Are we translating? No, because you changed the orientation. Is it a dilation? Nope. It has to be a rotation, right? It is. It is a rotation. And you can kind of cheat it. If you rotate your paper, right, one turn to the right, that would be 90 degrees clockwise. If you're not sure, you could actually just take the coordinates at this point, plug them in, see what these coordinates are, and make sure it matches up with the rotation rules. But in this case, you don't really need to do that. So this is a rotation, followed by a what? Let's see. Is this another rotation? Nope. Is this a translation? No, because the orientation changed. Therefore, it is a reflection, and lo and behold, looky here, our line of reflection is the x-axis. So it is a rotation followed by a reflection. Okay. I like that problem a lot. That's a good one. Okay, here we go. This can be a little confusing if you read this really quickly, but it's not really that bad. Math is shown on the coordinate plane. Math will be reflected over the line y equals -x to create m prime, a prime, t prime, and h prime, so math prime. Okay. So we're reflecting over the line y equals -x. So y equals -x is actually going to look like this. That's the line it's going to look like, and then it's going to reflect over itself. There's a, it's going to fold in on itself. Excuse me. Will each of the listed parts of math prime be the same or not the same as the pre-image? Okay, so the coordinates are going to, oh, they're tricky. So the line of reflection, it's actually really important that you draw the line of reflection here for this reason alone. Because M is on the line of reflection, it's not going to change the coordinates, because if you're on the line of reflection, you don't change where you are. So this would be the same. Coordinates of A, though, I can't, let me see if that's on the line of reflection. This is -4, +5, so this would not be on the line of reflection, so that would change. That'd go down here. The perimeter of M8, yeah, so perimeters aren't going to change because the same size, same shape, because it's a rigid transformation, so the perimeter would stay the same. The area would stay the same as well, because again, it's the same, same size, same shape. The angles aren't going to change because it's going to preserve congruency. The slope of HM is going to change because the positioning of it's going to change. It's going to go over here. So instead of having a negative slope, well, it's still going to have a negative slope. It's going to be a different type of negative slope. Yeah, it's going to be a different type of negative slope. So it's going to be the same. Let me show you how that changes. Hold on a second. All right, so just to show you that, let's let's calculate what h is here. M is going to stay the same, right? So h is -8, 5. H is -8, 5. And then h prime, if you reflect it over the line y equals -x, you're going to flip these and change both of their signs. So it's going to become -5, 8. So this would go, h prime would be all the way up here. So the slope or rate of change from h to m is, let's see, so it's 5 to 1. So it's down 4. And then 8 to 1 would be 7. So it would be -4/7. That's the original rate of change. The new one, -5, 8. So we're going from 8 to 1. It's going to be 7, -7. 5 to, and it's 4. So we're just flipping it. It's the reciprocal. So anyway, it's definitely different. So that's gonna, why did I put the same? I don't know why I did that. I'm gonna blame brain fog, I guess. All right, so yeah. So the only things that are changing here are the actual coordinates of A prime and then the rate of change here. I don't know why I did that. Okay. All right, so that's it for Unit 3. Hopefully that was helpful and not too confusing. Let me know if you have any questions. Thanks, guys.